Good morning, COM 3928, Dr. Mueller, 11 a.m. on Monday, and thought I'd work ahead a little bit. Wanted to show you some exciting, surely exciting to me, I hope exciting to you, some updates and changes from our data. And you know, one of the assignments, of course, that'll be coming in tomorrow, and is about reliability testing. And appreciate some of you sent me emails. I know you're working through this assignment, and you know, had asked again, help me understand again, what does it mean? Well, again, when you're trying to build a scale, and some of them, again, we took out of literature, they already have existed for a long time, like Rosenberg scale or that narcissism scale, right? They've been around a long time. They've tested for good reliability again and again and again. That's why they're in literature. Okay, and again, what that means is, and I try to teach this class in a good, simple, understanding way. I've learned over time, this is a communication program. You know, you're not in a statistics major, you're not in a mathematics major, you know, you're not in a, you know, any kind of business major. So we learn it in the basic sense so you have a general understanding. So reliability is really, picture this, all of the respondents, what we have up 900 or whatever, close to 900 respondents, they're all answering all the questions to this survey. And remember, let's say each answer from each respondent is a dot. And the way it was taught to me by my mentor at University of Florida, back when I got my doctorate and I was struggling in statistics, he would say, think about this, every dot from every respondent for every answer, there's thousands and thousands of dots. And he said, let's say they're all floating around this room. What JASP or other statistical software does is it looks for all these and it then starts looking for patterns. Like as all these people answered the 15 statement items that we created in our class, right? We created 15 items that we hoped would measure self-esteem. JASP is looking for all the similar patterns in answering. And that's how we get the Chronbach alpha, right? We really need a 0.8 or higher from that Chronbach alpha test to tell us all of those items are working closely enough together that they are all measuring the same construct. And in this case, we're trying to measure self-esteem. Okay. Well, I think you've determined by this point running those tests, what do we have, a 0.72? It's not good enough. It didn't work. Okay. So I thought, well, we've got 15 items, and that can be a lot for a scale. And I thought, for 0.72, what would it take to get our scale to be reliable, have that internal validity, you know, that we need among those items? So really what that would mean is we would need to reduce some of the items. Okay, so let me show you in reliability testing how I did that. And then the big news is I'm going to give you an updated data set which now has 10 items. From our 15, I reduced it to 10 that now represent they are reliable together. Okay, now one other thing, and I apologize for this, in one question. If you get stuck, give it a good try for like 15, 20 minutes, a half hour. Some of you I know really got stuck and then finally contacted me and I could fix it for you fast. One thing, some of you may have not seen the reliability test up on the top of your JASP console up on top here. I apologize. If you ever don't see something I tell you to use, see this plus sign over here? Click on that. And that shows you a lot of different things you can have in or out of. You custom designed this control panel on top. Okay, so you know, I could take out these equivalence tests. I might take out machine learning. We're not doing that in this course. You know, we're going to use network analysis, reliability, structural equation modeling, no, summary statistics. So does that make sense? So you choose, so if you don't see something, I apologize, click this plus and then you customize what you want for testing on top. But of course, what we needed for that assignment was reliability. So we click on that and that's classical single test reliability. And then again, I'm going to go down here and what I'm going to do is grab up the 15 items that we used in our test. And And I believe it, I've done it so much now, I think these are the 15, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. Okay, so here's the 15, and then remember here, these are all kinds of different types of testing. We will use Chronbach, and then Chronbach if item dropped, okay? We want to run that on those 15, okay? So then I'll show you what I did. And let me let this run. I know it takes just a second to get this to run through. And then I'll go ahead and show you what's happening. Again, dots in the room. This is taking time. JASP is looking at this. How does this fit? You know, are these measuring in the same pattern across all these 15 items? Does this make sense? Is it going to work? Okay. Okay, so we're back in it, and I remember it's 0.72. It's just not good enough, right? So you go, okay, there's nothing wrong with that. It just means our items are okay. The statements we created are okay. They're just not working well enough together. So then I always check this. What if I dropped any items? Does that bring the Chronbach? Does that bring the reliability up? First of all, I look up and down here, and there's no one. Sometimes you'll find one item that if you just remove one, the whole thing comes way up, which means you just had one sort of bad ringer statement among all of them, right? We don't have that, okay? But there are some here, if we start at 0.72, you know, there are some here. Here's a 0.76, 0.745. And so what I did, just to get started, I go, well, let's pull some of these out and see what it does for the alpha, the Chronbach alpha. Okay. So I pulled out, let's see, I think one of them here is other people appreciate who I am. Of course, if you pull that out, it brings the Chronbach alpha up. I pulled out the one about forming opinions. Okay, so let's do that right now. Let me do this, and I gotta think about this because you know I got notes on all this when I did it. And so the first one I pulled out is appreciate who I am. Okay, so I'm going to take this appreciate who I am and take that one out. Okay, and then there was one here about form opinions. Okay, so that's this one here, form my own opinions rather than agree with others. Let me take that one out. That one didn't really, you know, that lifted the alpha just a little bit. And then there was one other one about incorporate traits. Incorporate the admirable traits of others, and that lifted the alpha a little bit if we took that one out. So look, I took 3 out now. 3 out of our original 15, and of course now it's recalculating the Chronbach. Okay, so we look here and remember it's this point estimate. That's what we're looking for. Boy, we're all the way up to 8. If we round this up, we're at 0.8. Oh, we're just there. And I thought, well, we took out 3 items. Can we get it just a little bit higher? Okay, to make sure we really have that reliability we need. So then I looked at the rest of them that are left here and what would lift it above 7.9. Well, there's a couple here. Here's one, work on our troubles. Well, that didn't, if we pull that out, that lifts the alpha even a little bit more. And then there was just one more, how actions affect I had this other one, how actions affect those around me. Okay, so I pulled that out. I've pulled 5 of our 15 original ones out. Now let's let it run and see what we get for our alpha. There it is. Now look what we've done. Now we have a 0.82. It is noted to be reliable. It's you know, clearly enough above 0.8. We've got a 0.82 and we've reduced our scale from 15 to 10. Okay? So in the next data set I give you, there will be 10 items there. Now what I want you to do is, you know, go to your coding sheet and go ahead and I hope you can see that cross through the ones I've just eliminated. Okay, you can watch this video, you can check the 5 again I took out, and you can go ahead and please cross through on your coding sheet the 5 I removed, because from now on when we're working forward, you won't be seeing those 5. We're going to reduce our scale down to 10. But that's, again, when you're working with data, once you get the survey results back, raw data, right, you clean it and then you keep working it. You see if you can improve it. You look at the reliability. Sometimes that means eliminating certain items, okay? But we just went from 15 to, we're going to now work with 10 items in our class scale. That's fine. And we have removed the, by the way, who's ever associated with those ones we removed, that doesn't mean they're bad. It just means they weren't working well within the group of statements that we're trying to provide. Okay, so now we've created 10 items that we'll be working with through the remainder of the course. All right, now for the next assignment, we're going to do correlation and network analysis, and they're related, okay? Correlation really tells us among the variables we're going to look at in our class, that remember we're going to be working with 10. Let's test those 10, the 10 that remain of the 15 that I just showed you. And remember, the new data set I'm going to give you will have just those 10 showing. We're going to run all 10 of those in correlation, and what it will tell us is which ones pair together the most and the power of those pairs. Okay? So, you know, what is it about them that make them work together? Okay, so let's do that. And by the way, here I did use a different sample set because I want you to use our sample set to get your full learning outcome. You know, if I show you exactly all the results of our sample set, then all you're doing is replicating it. I want you to run it, see it for the first time, and then interpret it, okay? So this is a different sample set, but it will surely show you how to do it. So here's regression. Click that in JASP, regression, and then hit correlation. Okay. And in this one, let's go ahead and let's just say I'm going to move the 10. This was a cancel culture study that I did with a class, and it's 10 items, so it'd be similar to our 10 items, and I'm going to move those into variables. And here you go, Pearson's R should be checked, and go display pairwise. That helps. And check. That's all you really need to do. I think these 3 right here, just check that, okay? And then again, it's going to run for a bit just to fit all these together. And again, this time it's looking for, of all the combination of pairs, which ones are most highly paired together and what's the strength of that pairing, okay? Looks a little complicated, but not bad. Let me tell you, here's the first time we're going to talk about p-score. This is the let's call it the probability of success in the answer, okay? When we work with p-scores, please listen to this. A p-score always has to be less than 0.05. It has to be less than 0.05. Okay, anything higher than 0.05, it is not significant. If the test is not significant, we don't do anything with it because it means the test didn't work. It didn't mean anything. Okay, when you see a significance like this, less than 0.001, that indicates it's highly significant. Okay, and if you look down here, I'd start there and just glance down. These are all the pairings. These are all the pairings of our 10 items. Or this is a different data set, but think of this, of our 10 items, all the different pairings. You can go down this list, and what I would start with most, just see how many are less than 0.001. That means those are highly significant pairs. Okay. There's a lot of them, isn't there? Among all those combinations, there's a lot. Here's what I think is most important then. Pearson's R tells you the strength of that relationship. Okay? Not only that it's significant. Okay, we know it's significant, but now let's look which ones have the highest strength. If a Pearson's R is 1, that means they're perfectly correlated. They're trending exactly the same. In this case for you, I would say let's do this. let's look for the top. Once you notice they're highly significant, less than 0.001, then decide the top 3 Pearsons are. Okay, and it takes a little time, but just sort of, go to glance down the list. I see a 0.273. I'll just think, well, so far that seems to be the highest, right? Yeah, 273. I'm still looking. There it is. So there's a 273. And then what would be second? Well, I see a 2.2. Here's a 0.259. Okay, so in this one, we've got a 273. So here, know more about somebody's character and debate diverse perspectives. That would be the top correlated pair because it's highly significant and it holds the highest Pearson's R at 0.273. Okay, so of all the combinations of these 10 items, you would know that people debate diverse perspectives also want to know more about someone's character. This is our first inferential test. Okay, inferential. It infers things. It starts telling us about the psychology in the data. Okay, or what the data tells us about the psychology of our respondents. Okay, and then down here, this 2.59, people who debate diverse perspectives also learn from mistakes. Okay, so those would be the top 2. I say for us, let's just look for the top 3 and then you can report on those. Okay, so that's how you really look at this. Now, there's one other thing I want to tell you that's important. If you ever see a negative, that indicates a negative correlation. Okay, so listen here, please listen carefully. When there's a positive correlation between 2 items, like a correlation between 2 statements, positive means they move up and down together. As one moves up, the other moves up. As one moves down, the other moves down. That's a positive correlation. It goes up and down. Those 2 statements go up and down together. If you see a negative correlation, a negative Pearson's R, that means as one goes up, the other goes down. As this one goes up, this one goes down. Now let's just find one here and I'll make an example for you. Here, negative 0.154, highly significant. It's acceptable to dig into a person's past. People learn from mistakes. As people believe it's acceptable to dig into a person's past, they believe less that people learn from their mistakes. As people believe they learn more and more from mistakes, they believe it's less acceptable to dig into a person's past. Do you see what I'm saying? They push against each other in a negative correlation. They push against each other. That's going to come up in this course. So as you look at this, always look for the highest significance, and then for this assignment, the top 3 highest Pearson's R. But be very careful to note if among those highest 3, if they're all positive, that's one thing. If there's a negative in there, you need to report what the negative relationship means. Okay, that's it for that assignment. That is correlation, and again, that is our first big step at inferential statistic and result. All right, thanks. All right, so the last big test, or the test we'll run for this assignment is network analysis. I think it's fun. Network analysis is really taking a lot of what you saw in correlation, looking at all those pairs, but it puts it into a big visual for you to take a look at. And I think it's fun, and it's always great for reporting to the client. I think it is, okay? So you go to network here, and then it would be the same thing. Let's move in, for you it'll be our 10. Remember, 15 reduced to 10. I'm going to give you our 10 remaining self-esteem measures that we created as a class. And you will move those into here, dependent variables and network. Okay, for our testing, and this is called like an estimator, it's a modeler. It picks different kinds of models. And for the best learning opportunity for you, I want you to go to this iSync fit. That's one way of it's twisting the dots. I like that model because it helps you learn. Then go network plot right here. Okay, click that. Let's see, down under graphical options. And by the way, I'm going to give you a graphic of all this in the assignment so you'll know what's going on. Let's see here, you click in legend, because you definitely want this showing up in legend. I'll tell you why in a second. You'll see why. Okay. Down here where it says legend to plot ratio, this is where it shows the labels. And this is just a way of fitting the labels properly into the image. And I did this before, so go 1.3 legend to plot ratio. Okay. And I think that's it. Let's see what happens. It takes a little bit time to run. Again, you know, it's got to look at all these dots and figure out how to interrelate all of that. Okay, so just understand your graphic is going to look a lot different. It'll be similar to this in layout, but it's going to look a lot different. Okay, this is what a network analysis is. These are all test questions. The circles, which indicate each of these are a statement, that's called a node. Okay? The lines connecting the nodes are called edges. Edges. Okay? If you see a blue, the darker and thicker the blue, the more powerful the relationship between the variables. A thinner purple line means there's a relationship, but it's weaker. A red line indicates a negative relationship. We just talked about that in correlation. This is interpreting all these together. Now again, yours is going to look a lot different. Where you start in a network analysis reporting is look for a hub node. A hub node is a node that anchors other nodes. It's sort of the big foundation of the thing. Here, the hub node is 10, because if you look on this, hub node 10 anchors 8 and 9. Does that make sense? So hub node 10 says critical thinking is essential and important. That anchors controversial thinking, usually shifts over time, and immoral, illegal, unethical should be held accountable. So these three are really strong together, but anchored by the hub node, critical thinking essential. Okay. Now you notice there's also a weaker relationship down from the hub node to 5, which means learn from mistakes. So you can this is great because you'll be able to see the interrelationships among our 10 remaining statements and what that means visually, okay? And always look at this. Here's a negative hub node, 7 in this model. It's acceptable to dig into a person's past. That's negatively related to know more about character and learn from mistakes. So once again, let's think about that negative relationship. As one thinks it's acceptable to dig into a person's past more and more, they're going to think less and less about learn from mistakes. I believe that was that highly correlated pair we saw negatively in the correlation, I believe. And then also acceptable to dig into a person's past, people who believe that, against know more about character. So as someone, again, they think more and more, boy, it's acceptable to dig into a person's past. Know more about their character is going to go down. I want to dig into their past, but I don't care much about their character, right? As people care more about someone's character more and more, they're going to think it's less acceptable to dig into their past. Negative relationships moving against each other, away from each other. Okay? So that's network analysis. And I think that will conclude the instruction for today. Thank you.